Welcome to this video. In this unit, we're going to learn about circular motion. Let's say I'm walking down the street, and my velocity vector is like this. I'm walking along the road. Now, if you think there's some danger, like maybe there's a car speeding by, and you're afraid I'm too close to the road, right, here comes the car, you are going to try and turn me away from the road. To get me to move away from the road, to get me to swing around like this, you have to push me perpendicularly to how I'm moving already. So if I'm moving this way, you have to push me perpendicularly with a force like that in order to get me to turn. Let's watch the same scene unfold when viewed from above. Here I am, and I'm walking down the page. There's a car coming, and you want me to turn to the right. So how do you push me? You push me with a force perpendicular to my velocity. If you came along and if you tried to push me with a force like that, I would just speed up. I wouldn't turn. If you came along and you pushed me with a force like this, I would just slow down. I wouldn't turn. To produce turning, a perpendicular force is needed, and here's what we can say. Now, let's say you want to cause me to move along a circle like this. What do you have to do to make me move along a circular path? Let's draw the circle again over here. At first, I'm moving straight down. My velocity is downward. Right? Let me make that a shorter arrow. I'm moving straight down. But you turn me by pushing me with a perpendicular force. And so, instead of moving straight down, I move like this, along this path. And now my velocity is directed along this angle. But you turn me again by pushing me toward the center with a perpendicular force. And that causes me to move like that, with the black line shown. And now I'm moving along a different angle, like this. But you turn me again. You push me yet again with a perpendicular force. And so I continue traveling along a straight line, but that straight line changes direction because you're always turning me with your perpendicular force. So as I move around this circle, the direction of velocity changes, and the direction of the force changes. So here's what we can say. Now there's something more that we can add about the net force, the red arrow. At this moment right here, the net force points toward the center of the circle. At this later moment, the net force still points toward the center. At this later moment, the net force still points to the center, and likewise here. At every moment that you move along the circular path, the net force points toward the center of the circle. The way we capture this is by adding the word centripetal. The word centripetal means center-seeking or pointing toward the center. Another important thing to notice is the velocity vector here. This velocity vector is always directed tangent to the circular path. So if you want to know where does the velocity vector point right here at this moment in time, all you do is you imagine a radius connecting the center to the person, and then you draw a line perpendicular, let me use blue, perpendicular to the radius, like that. If you want to know where does the velocity vector point right here at this moment, you do the same thing. Draw the tangent line. So imagine a radius line first, and then draw the velocity vector perpendicular to the radius line. Here's what we can say about those two vectors and their directions. Take a moment to read the screen.